I just want to thank each of you for joining us today as we kick off the first of our DAS webinar series. This is a series of 7 presentations. Vision's a leading IT services company headquartered in Baltimore, Maryland. We've teamed with our OEM partner CommScope in order to provide you with pertinent information and a roadmap to the life cycle of a DAS project. So I just wanted to share with you briefly kind of the calendar of events that we have. Today's presentation is a very basic overview of a DAS. As we progress through our series, we'll definitely go more in depth as far as partner selection, needs analysis, system design, product selection, DAS deployment, and also maintenance. We muted your phones at this time, but we want you to encourage you to ask questions. There's a chat feature that you should see. Please feel free to type your questions throughout the presentation. We probably won't have time to cover all of the questions necessarily, but we'll try to answer as many as we can at the end. And then if we don't get to it, we'd like to be able to contact you and make sure that you get the information that you need. So last thing before we get started, I just want to introduce Ron Plekas. He's a member of the CommScope organization and is responsible for managing in-building wireless channel sales. Pairing his technical expertise and 14 years of experience, he's a wealth of knowledge. So at this time, Ron, I'm going to kind of turn it over to you.
Thank you, Virginia. Appreciate it. Welcome, everybody. The topic today we're going to cover is basically, as Virginia had stated, just we want to kind of start off with the basics, and each one of the series will kind of build from that. So we're going to go over basic terms. We're going to talk a little bit about what a DAS is. There's different flavors of DAS. Kind of break it out in terms of the components and the parts and pieces and different considerations that need to be taken into accountability. So lots of jargon, just like any other technology. You'll hear the term IBW, which stands for in-building wireless. You will also hear the term WSP, which used to be called the wireless carriers. Now it's the wireless service providers. So that's AT&T, Verizon, Sprint, all those folks. HetNet is a term that we don't hear that often, but you will start hearing it more and more. It really, from a generic perspective, it's really talking about a network that connects computers and other devices with different operating systems. In the DAS world, it's a wide area network that would use macro cells, picocells, or even femtocells to offer wireless coverage either inside or in some cases outside. So that's the term HetNet. Other things you will hear about, DAS is basically a distributed antenna system. You'll hear the term cellular enhancement. You'll hear the term radio frequency repeater system. And one of the things you'll hear is either a neutral host or a multi-carrier solution. And we'll talk a little bit about that. From a technology perspective, the G on each one of these stands for generation. So we've gone through a whole series of generations. Most of you are experts on LTE, which you see advertisements from all the carriers that they have the best LTE network, and that is a 4G technology. And please be advised that LTE is data only. So that's a big change in our market back when we were only doing voice. And then right around the corner is 5G. So RF signal sources, we're going to talk about a couple different things. From a booster perspective, we'll talk that could be a cellular repeater. You may hear the term bidirectional amplifier. You're also going to hear the term BTS, which is a base transceiver station. That's a fancy word for the cellular switch that sits in a cell site. And then there's something called small cells that are starting to take place out there. So that's kind of an overview of some of the jargon, if you will, some of the terms that you will hear over and over again. So what is a distributed antenna system? It's really pretty simple. You basically are taking a signal from the outside network or from a dedicated RF source, and then rebroadcasting that inside a building. And there's different parts and pieces of that. So from an in-building wireless perspective, we take that signal, we make sure that that signal is dominant inside, and make sure that if someone's on a call and they're inside on the distributed antenna system, they can walk out the door and transparently that call will transfer. We also have to make very sure that it doesn't have an impact on the outside network. So there's different subsystems that are part of the in-building system, and I'll go through those in some detail in a few minutes. And then the signal source, again, we've got either one of two flavors, either a dedicated cell site, which we refer to as BTS, or an off-air repeater. And there's different applications for this. It's not just cellular phones. We also do a lot of work with public safety entities and even land mobile radios. So all of those can go down a common infrastructure. Okay, the building blocks. There's really two basic building blocks. What I call the wireless carrier interface, and all that is how do I bring the signal into the building, and then the distribution system itself. How do I distribute that wireless signal? And that's the two parts that we're talking about today. So the first option is basically putting an antenna on the roof, pointing it towards a cell site, and bringing that signal in from the outside network, which is referred to as the macro network. Please be advised, though, in this particular case, many enterprise clients think that they can put one antenna on the roof and bring the signals in from all the carriers, and it doesn't work that way. We would need to have donor antennas for each respective carrier. So that's a very important consideration. And keep in mind also that we're sharing the signal with the outside network. So under option number one, that's basically the repeater or the bidirectional amplifier. We've pretty much covered this, keeping in mind that each one of these units is only supporting the specific frequencies of a specific carrier. So if I was doing AT&T, Verizon, Sprint, I would have to add, in T-Mobile, I would have to have 4 different sources to feed the in-building wireless system. The other option is the cellular base station. And basically, again, that's a dedicated cell site that feeds that particular location. It connects to their outside network through T1s going back. We're getting some background noise. I'm not quite sure where it's coming from, Virginia. Can you perhaps mute? Okay, so the next question, and a key component is when you're talking to a client, who decides which particular way you go? Who decides whether it's going to be a repeater or it's going to be a base station? And that decision is made by each one of the wireless service providers because we are touching their network. So they're going to ask certain questions. They're going to want to know the number of wireless subscribers that would be on the DAS. And then they'll go out and they'll take a look at the traffic on the outside network on the particular serving site that we would be pulling signal from. And if the traffic is not going to have a negative impact on their overall macro coverage, then they would go with option number one and allow us to have a repeater. So again, some of the things to think about from a customer perspective, and again I'm talking about an end user on these two options, is if you're using a repeater, there's an issue of ambiance. You know, we're going to have to put antennas on the roof. There's no zoning required, but you still have to put these on the roof. And we have to be able to pull cable up to the roof, so we deal with issues like roof penetrations. Working closely with the company that provided their roofing to make sure that we don't void the warranty on their roofs. And then we also have to go up during the early stages and we have to make sure, are we getting enough signal outside to be able to support the application? For option number two, the base station, we're really talking about a space consideration. As you can see from the picture on the right, in some cases each carrier may need 4 cabinets, 4 24-inch racks of equipment. So that becomes a factor that we bring up early in the discovery process to make sure that the customer is comfortable, number one, that it's not our call, and number two, that they have space available for that. Okay, the fiber head end. That's basically where we bring in all the signals, whether it's from a base station, whether it's from an off-air repeater. We bring everything into a common infrastructure, and from there we convert everything from RF into light. So at this point, from where that circle is down at the bottom, we're basically combining all those signals, and then we're going down either single or multi-mode fiber out to a remote unit. And again, single or multi-mode fiber is the transport for that. Covered that. So the remote units, what happens there is they actually have amplifiers and converters built into them for all their respective frequencies. And what they do at that point is they take that light that comes in, they convert it back to RF, and then we feed the antennas in a couple different ways. One of the ways we can do that is with half-inch coax, basically going out to antenna points. We're also we can also use Cat 6A, which is more of a structured cabling situation, and it's something that many people would prefer using going out to the antennas. What do the antennas look like? Well, I'm showing you three flavors here. At the very top, we have what we call a directional antenna, and what that is you may have a situation where you don't have access to the ceiling or you want to put something on a wall, so that would be where a directional would come into play. The other two antennas, the one at the bottom, the CellMax, that's what's referred to as an omnidirectional antenna, which means it can propagate signal 360 degrees. And the one on the far left is also an omnidirectional, and it can be either ceiling or wall mounted. Okay, we have this very, very nice animated slide here that doesn't animate in our current situation, so I'm going to have to just kind of walk you through. So very high level, how do we bring the signal into the building? If you look at, we have two different ways of doing that. We may be using a microcell or a picocell or some type of a base station from one of the carriers. We may be using an off-air source for some of the others. So it doesn't have to be one size fits all. It could be a combination. And then basically all of that gets combined into a master unit. And then it goes from that, it goes basically from the head end here out on fiber. And then from there it's going to be connected to a remote unit, which is typically sitting in a closet. And then from that remote unit, we go out to antenna points either with Cat 6A or with half-inch coax. So all we're doing is basically passing the signals that they're providing us. So some of the things that you need to consider is the fact that I'm sure all of you have Wi-Fi at home in your offices, and Wi-Fi is what's referred to as an unlicensed frequency. By that I mean no one owns those frequencies. So in the case of the wireless service providers, the frequencies that they use are licensed frequencies. They actually purchase those frequencies from the FCC. So they're regulated by the FCC. You have to go through a formal approval process to get permission to use those in a distributed antenna system. And if you don't follow those rules of engagement, there's many things that can happen. It's not uncommon for a carrier to go into a location that hasn't gotten permission and actually shut that system down. So we cover all this right up front with the enterprise client to let them know that there are specific rules of engagement for that. Okay, some of the other things that are key is the fact that the design that you provide for a distributed antenna system, even if the wireless carriers are not paying for it, still has to be approved by the wireless service carriers. So the frequencies that they're using, they have an approved product list in terms of what products they expect to use. They're going to determine what the signal strength, those bars on the phone that you have, are, and also the quality of the signal that's coming into the building. They have metrics that they require. And they're also going to require a dedicated RF source, as I told you before. Each one is going to feed the DAS with their own. And then once the project has been approved, the acceptance package that goes in to get the sign-off by the carriers, it's required that it has to be done in an approved software package, and that is referred to as IBWave. That package is going to include a layout of all the components and the cable paths. It's going to require a link budget showing the loss from where the signal comes in going through the entire system, and then a propagation analysis showing what the signal strength is within the complex by location. So today, what do we talk about? We talked about different options when deploying a DAS solution, whether it's passive or active. I didn't really highlight passive, so let me just give you an example of a passive solution. A passive solution would be done in a very small space typically, or a public safety only system. And instead of using electronics, it's basically just the feed coming into the system and then just going out to antenna points over coax. That's referred to as a passive solution. So there's two components, as I mentioned, in a DAS system: the carrier interface, bringing the signal in, and distributing the signal. A key point number 3, that the wireless service providers are stakeholders in this process, regardless of who's paying for it. And again, under that, the fact that the license frequencies require specific requirements for deployment. But at the end of the day, who's responsible for the deployment of a DAS? So I'm going to turn this back over to Virginia.
Thanks, Ron. I really appreciate it, all of your information that you provided. I'm just going to move to the next slide here really quickly. This is just a quick announcement as far as our next session that will be on May 19th. It will cover how to select a trusted DAS partner. At this time, just to wrap up, I wanted to share a couple of the questions that have been asked. Ron, please respond. So we'll just kind of start with a couple of quick ones that came towards the beginning of the presentation. How long does the carrier approval actually take? I think that this is kind of an important question that a lot of people tend to ask.
Yes, thanks, Virginia. Yeah, that's a very important question, and that's something that you have to set the expectation with your customer early on. We're currently, this industry is over 15 years old, and when we first started doing this, it was pretty simple. You could make a phone call and you could get something approved and be on air in a couple of weeks. That is no longer the case because of the fact that there's so many people deploying DAS systems today, and the fact that the carriers, as you may or may not know, are having their own troubles just in the outside network. So as I speak today, the wireless carriers in the United States are in the process of doubling the number of cell sites across the United States. And the reason they're doing that is because most of you on this call are probably active data users, and data uses a lot more bandwidth than voice. And the closer I can be to a cell site when I'm outside, the better off I am in terms of data speed and things like that. So we tell people right now that it could take anywhere from 6 to 9 months to get carrier approval. And again, you need it from each respective carrier. So our best practice is once a project kicks off, you identify that project with each respective carrier and start working with them from day one. They appreciate that, and in most cases you can accelerate the process. But from a guideline perspective, 6 to 9 months is not an unreasonable time.
Perfect. Okay, here's another question that we were asked. How are upgrades handled?
How are upgrades handled? Okay, well, let's talk about that. So let's say we had a system that went in before 4G happened, and 4G LTE, which is all data related. What can happen is, and we've had a number of those recently, so we can basically, we as an OEM or any of the OEMs can go back and basically add feature sets, if you will, to support that particular frequency band. And that typically on our system, that would take place at the head end. So that master unit we talked about, we would have to add additional cards, and then we would have to have additional feeds from the carriers, and then we would be able to support that. If we're talking about upgrades in terms of adding additional capacity, then that's just a matter of being able to make sure that the head end that you have has enough ports and things like that to be able to support additional fiber runs and things like that to go out to the remotes to give you the antenna coverage you need. And the beauty of our system, again, is the fact that the master unit can be actually, if you've run out of ports, you can add a separate rack and continue to grow the system. So it gives you a nice path to grow and expand.
Okay. Maybe one last question here, Ron, and then we'll certainly try to address everybody else's questions separately after this presentation is over. So if we haven't covered your questions, don't worry. We would like to still be in contact with you. So last one for you, Ron. Who manages the installation?
Okay, good question. It really depends on how the project comes about. If you look at a typical distributed antenna system, there's two scopes of work. You have the one scope of work, which involves getting that carrier approval, doing the system design, doing the commissioning, and getting the sign-off on the certification that the system meets the OEM's requirement. So we have business partners that do that. Vision is one of our top partners in the United States. The other part of it is actually pulling the cable and hanging the electronics and all that. And that can be done by, it may be a preferred vendor by the enterprise, or it may be a situation where one of you on the call today has identified an opportunity and come in. So if that's the case, if you've identified the opportunity, you can certainly take the lead and then sub out the commissioning piece to one of our business partners and do it that way. Or in some cases, we'll have our business partner will identify an opportunity, and then they will bring in companies to help them do the cabling and things like that. So it really kind of depends on where that lead actually came from.
Great. Well, again, I think that's all the time that we really have for today. We want to thank everybody for joining on the call. If you missed any portion of the presentation, we will be making it available so that you can review it at a later date. If you have any questions, I just have one more slide on here I want to show to you. This is contact information for Ron and also for Rick from Vision Technologies. Rick was not on the call today as a presenter, however, he will be joining us on later sessions. So thank you again. Remember, May 19th is the next presentation, and we'll be back in about a month.
Okay, thanks everybody.